Hello, welcome again. We are solving some questions of manufacturing science or production engineering. The topic is metal cutting. Question number 42 is a batch of 10 cutting tools could produce 500 components while working at 550 rpm with a tool speed of 0.25 mm per revolution and depth of cut of 1 mm. A similar batch of 10 tools of same specification could produce 122 components while working at 80 rpm with a speed of 0.25 mm per revolution and 1 mm depth of cut. How many components can be produced with one cutting tool at 60 rpm? Option A 29, option B 31, option C 37, option D 42. So here now we know from the tool life equation, Taylor's tool life equation, Vt is for n is equal to constant. So here the RPM are given. So velocity is directly proportional to RPM because velocity is pi dn by 60. If we take d as constant and then it will be directly proportional to RPM. And T is tool life, and tool life is number of component produced per cutting tool. Directly proportional to number of components produced per cutting tool. Okay, because higher the tool life, higher will be the number of components produced by that same tool. Okay, so T can be taken as directly proportional to number of components per cutting tool, and V can be taken as directly proportional to RPM. So in the first condition, number of components produced are 500 and number of tools used are 10. So number of components per tool is 50. So putting here the value of V as 50 and T as 50. So 50 into 50 rate for N is equal to C. And for a second condition, number of component will be number of component per tool is 122 by 10, that is 12.2. Okay. So and RPM is given as 80. In first it is 50 rpm and in second 80 rpm. So equation becomes 80 into 12.2 for n is equal to C. So that is equation number 2. So dividing 1 and 2, we have 50 by sorry, dividing 2 and 1, 80 by 50, and sorry, we dividing 1 and 2, we have 50 by 80 and 50 by 12.2 rate for n, and just 50 by 80 can come here, that will be 80 by 50. So taking log both sides, we have n ln 50 by 12.2 and this is ln 8 by 5. So solving this, we have n is equal to 0.33. So now the constant becomes 50 into 50 raised to 0.33 is equal to C. So that will be 181.81. Okay. Now when the speed is your 60 rpm. Okay. So now we have to find out the number of components produced, because T is we have taken as number of components produced per tool. Okay, and V is 60 rpm. Okay, so VTN is equal to constant and C is 181.81. So T comes out as N is your 0.33. So T comes out as 828.27. So this is your number of components produced per tool when the speed is 60 rpm. So answer is option 29. So answer is option A. Okay. Next, question number 43 and 44 carries a common statement. The statement is a low carbon steel bar of 147 mm diameter with a length of 630 mm is being turned with uncoated carbide inside. The observed tool lives are 24 minutes and 12 minutes for cutting velocities of 90 meter per minute and 120 meter per minute respectively. The speed and depth of cut are 0.2 mm per revolution and 2 mm respectively. Use the unmachined diameter to calculate the cutting velocity. Question number 43. When the tool life is 20 minutes, the cutting velocity in meters per minute is option A 87, option B 97, option C 107, option D 114. Question number 44. Neglect over travel or approach of the tool. When the tool life is 20 minutes, the machining time is in minutes for a single pass Option A 5, option B 10, option C 15, and option D 20. So when the speeds are 90 and 120, the two lives are 24 and 12. Okay, so using that two things and using Taylor's two life equation, we find out the constant of Taylor's two life, that is n and c. So v is your 90 and n p is your 24. The equation is 90 into 24 is for n equal to c, and for the second condition it will be 120 into 12 is for n is equal to c. So dividing these, dividing 1 and 2, it will be 24 by 12 raised for n, and this is your 3 by 4 is equal to 1. So 2 raised for n is equal to 4 by 3, or n is your 0.1415. Okay. So when so the two life equation can be obtained from this or either of these. So taking this two life equation will be 90 into 24 into 0.415 is equal to c. So now c will be 90 into 24 raised to power 0.415. So now when the time when the two life is 20 minutes, so the equation is v into 20 raised to power n, and this is your 90 into 24 raised to power n. Okay. So n is your 0.415, and v becomes putting the value of n, v becomes 97 meter per minute. So answer is answer to question 43 is B. So two life equation, so the speed at two life 20 minutes is 97 meter per minute. So next is we have to determine the machining time in minutes when the two life is 20 minutes. So when the two life is 20 minutes, the speed is 97 meter per minute. Okay, and the diameter of the workpiece is given as 147 mm, and the length is given as 630 mm. Speed is given as 0.2 mm per revolution, and v is a 97 meter per minute. Okay, and time for machining is length by feed per minute. So length is 630 and feed is 0.2 feed is here, the feed used is in mm per minute. So here the feed is the given feed is in mm per revolution. So feed per minute is equal to feed per revolution multiplied by revolution per minute, or RPM. Okay. So now RPM can be obtained by this v is equal to pi d, and n will be your v by pi d. So f and this is your feed is given as f. So feed per minute is your f into v divided by pi d. Okay. So now we have feed per minute, that is f v divided by pi d, and we have length. So the time for machining is your L into pi by d, so pi into d divided by v into f. So now we have L is your 630 mm, and d is your 147 mm, d is your 97 mm, f is 0.2. No, sorry, v is your 97 meter per minute. Okay, so converting it into mm also. Okay, so we have t as 14.997 minutes or 15 minutes. Okay, so answer is option C. Okay.